Yeah, so we have one more presenter from the North American content. We have Silvana Ovaitt, who is a research scientist at U.S. National Renewable Energy Laboratory, NREL, and she is going to talk about the performance and degradation of bifacial modules. Silvana, thanks a lot for joining our conference and waking up really early to take part in our event.
Yeah, there. Now?
Yes, all good.
Perfect. Well, good morning, everybody, or afternoon, I guess. Thank you for having me here. I am going to be presenting some field results from our site at NREL. Now, mind you, these are modules installed in 2019, but I still see value in talking about specific field results because bifacial and the module technology is changing so fast. We are doing all of the standardized testing to understand it. And at the end of the day, we also need experience from the field to see if, even if all of these modules pass standards, and see how they are performing and how we analyze that. So that is the value that I see in this presentation. I wanted to take a second to talk about Duramet, which funded this project and joins work from NREL and the National Laboratory and Berkeley Laboratory. It's very focused on the material and durability aspects of the PV modules. So there is a lot of information on the website there. There's studies on crack, on the baked glass modules, on any and all types of degradation. Now, I guess you all know how we are definitely having a lot of bifacial, right? That is no new for anybody on this audience, both bifacial cells and bifacial modules. That is the trend now. But the interesting part is how fast the cell types have started to appear and then disappear and be replaced by new technologies, right? So we got monofacial PERC making most of the production, and now we have a lot of TopCon and a lot of silicon heterojunction starting to be produced, starting to be analyzed by all the people on this webinar, on this presentations. So there's definitely some potential risk and challenges, and that's why we need to study them and and also improve the standard testing to capture any new degradation modes that might not have been captured before, right? So in 2019, when bifacial was starting to become a big thing in the US, we managed to get 5 different technologies of bifacial panels. They were commercially available, and we installed them with their monofacial counterparts. So that is same cell technology side by side, just the different packaging. This allowed us to do a lot of understanding of the performance and the degradation on this technologies, right? So apples to apples, comparing the same type. The other nice thing is that we've had 5 years data, and a lot of this is open source and available, even the performance data, as well as the IV curves, EQEs, etc., that we've taken on the field. So go check out these links. I will paste them at the end of the presentation as well. But they are set up in Golden, Colorado, so we get to see 4 seasons, hot and even snow, that these modules are seeing. And again, as I mentioned, lots of measurements, front, rear radiance, albedometers, etc. The technologies under discussion, there are 4 PERCs and 1 silicon heterojunction. They span the variety of manufacturers. Some of them, we have a little more information about what the encapsulates, etc. And the nice thing is that we also kept control modules. So a lot of the data is comparing how the control module is doing compared to the fielded option. We have examples of half and full cell, as well as location of junction box and comparison 1-to-1 to that monofacial for some of these technologies. In average, and we present this on various webinars before, we are seeing gains between 6 or 5%, and originally we're seeing up to 8%. I'm going to talk about that in a minute. Right now, both the PERC and the silicon heterojunction, after almost 5 years, they are on the 5% range. And this field is big enough that we actually get to see, the steady state of the bifacial gain of the self-shading. So this is what we are also seeing from big owners on the field. Definitely not that 2019 20% gains that were advertised on the news, right? So more on the order of 5%. Now, that is the average. If we start looking at it by month since we deploy this, you can see that there's definitely a lot of variability. You can see when the summers, the silicon interjunction starts to do really well because of that temperature coefficient, lower temperature coefficient that Tristan was mentioning. But we're actually starting to see even some negative bifacial gains compared to the monofacials. And this is why we start to look more detail at the degradation. Because that bifacial gain, even that higher bifaciality of a cyclic interjunction, is not as relevant if your degradation is then killing all that energy gain, right? So there is a balance between having gain or having a high bifaciality factor and then having a good degradation on your modules. All of the technologies have reduced on that bifacial gain because they have degraded. Now, I'll take a second to say that degradation rate is different than performance loss rate, and on literature as well as probably in my presentation, I am using them a little bit interchangeably. Performance loss rate includes soiling and the angles of the panels and tracking errors and a lot of more issues on the field, right? Luckily, we are actually able to get both degradation and performance loss rate because we have the modules and the capability to take IV curves and get actual degradation rates, as well as tools that do a very good job with the performance loss rate calculation, like RD tools. To show you a little bit of how from field data you can calculate how is your performance loss rate, there are 4 steps. You have your performance data, and you have to first normalize it. And there are 2 methods for that. If you have irradiance and temperature from your modules, then you can normalize that compared to that measured data, or you can use clear sky based simulations. Then you have to filter, so select clear sky timestamps, remove clipping events, so any data that's clipped will not be useful to calculate your performance loss ratio, and remove low radius timestamps. You aggregate this into daily values, so now we're on step 3, and then finally you calculate that degradation year-on-year performance loss rate. So that performance loss rate varies year over year, and it's also been increasing for most of the technologies, or getting a little bit worse, right? Some of them are kind of stable on that performance loss rate, but indefinitely what you can see is that the bifacial technologies have an average degradation rate of minus 0.94 or performance loss rate compared to just minus 0.34 from the monofacials. And again, various of this, B, C, D, are exactly the same cell, just on different packaging. Now, rolling performance loss rate, this is not a very typical plot, but what it shows is that initial higher degradation that we expect in that first year on technologies, and then a stabilization. So that is, we are seeing that, but we are definitely seeing quite a spread on the bifacial, on the degradations, right? So we want to see this being flat, but also closer to 0 than what we're seeing here. So we did testing IV curves for the actual degradation, and what we saw was confirmation of that performance loss. And in general, the short circuit current was the dominant difference. Now, we are also seeing VOC changes, which are a little bit worrying. So we then proceeded to do diagnosis with various tools available. Some of these are more common on the research field, but you might have access as field owners or researchers to various of this. RD tools is open source. IV curves, you will need to be able to take a module simulation. IR imaging, it's pretty accessible for in-field testing. EL and PL, now we are getting into the perhaps more laboratory tools, although there are some solutions for EL in the field now, as well as, for example, handheld Raman and handheld NIR tools that we're starting to see come out as tools for diagnosis on the field. Going into a couple of the technologies and what we've observed, right? So we have this technology A, which was PERC, glass, full cell. And in the EQE, we observe most losses on the front side on the short wavelengths. So this is the EQEs for the front and the rear. And again, this data is available, this EQEs and IV curves on the DuraMat website. We can see how there is more difference on the short wavelengths. And on this particular technology, the VOC loss dominates. And it's again on the front. There was initially a lot of concerns like, oh, the backs on many research, the back was performing or degrading more than the front. We're actually seeing that the front is driving a lot of the loss. In terms of the PL, EL, and delete, we are seeing decrease in the intensity, which is typically a sign of voltage loss. And there are some bands of high recombination obvious on the delete. So doing a close-up to that, it is very interesting because we have dark edge patterns here on the PL and the EL, but they are hot on the delete, and this is not always the case, right? And this is suggesting areas with high carrier recombination. So there are some cell losses going on there. Technology C doing a similar analysis of this other one, which is also PERC, but now it's half cell. We have also front size, short wavelength losses, VOC and ISC loss. And we actually saw a lot of rear mismatch from the junction box and the frame, perhaps. So this, like little blip there on the IV curves. And same thing with the imaging, we are losing intensity, which is consistent with voltage loss. Zooming in on the patterns, now we see dark EL, PL, and colder delete. So the opposite of what we're seeing before, which suggests high resistance causing fill factor loss. So we're seeing, again, this technology is from 2019 having different degradation issues. This is a monofacial control, the monofacial comparison for this particular technology. And the other one was losing intensity at 55. This was at 75. So it's also losing some, also having that drop at the short wavelengths, but weirdly enough, some gain at long wavelengths. We do see from the EL some and delete some grid broken fingers near the edges, which I think Tristan mentioned. He was seeing this very commonly on modules now newer, right? So this is 2019. So apparently this is still a situation with those technologies. And finally, going to the silicon heterojunction example that we had, we have light coupling loss on both surfaces. So the front and the rear are both changing. VOC from front surface recombination and ISC loss from the encapsulant degradation. So looking a little bit more at that, at the encapsulant, we use a handheld Raman, which is not very common to show the change in the fluorescent background. And this is consistent with additives to protect the silicon heterojunction, right? So that UV absorbers. Now, what are we expecting? So based on ITRPV, we're expecting a higher value on that first year, which we saw in that performance loss rate plot. But then we're expecting a stable and pretty low degradation in the subsequent years of 0.5. And we're not exactly seeing that. So we're seeing higher values on this small set example at NREL. In terms of like bigger analysis or literature studies, so Jordan had this famous study of 100,000 studies getting to that same value of that median of 0.5, right? Now, this was data from 2021 with at least 2 years of data. So odds are it has 0 or at most 25% or 27% bifacials. But there's a couple examples of fielded results, and it's not that many. So we have this one from 2019 showing, again, kind of high rates of degradation, but this is modules from 2017. And more recently, we have, for example, the study on the UK also showing glass-glass degradation between 0.9 and minus 1.17. This is very high, and it has a lot of implications into the acceptance and the real production economics of a field, right? So putting it also into PV fleets, so NREL's analysis of 9% of the US utility scale PV, we are seeing a spread, right? So we had originally our points which were as bad as -2 performance loss rate. Some of the PV fleet are showing less, so close to what is expected with -0.5, and some are still on that -1.5. I wanted to close saying, okay, so what happens is we have this very high degradations. So reliability is every bit more consequential than the initial cost, initial efficiency, and initial energy yield on a project. This presentation by Michael Woodhouse, which is our techno-economic analyst, shows how it changes your cents per watt of your plant if you're then degrading at higher rates than what you expected, right? This is under different economic models, so the ITC and the PTC in the US. But it is very clear that if we are degrading and we're assuming this minus this 0.5% per year, but then it's 1% bigger, it's really affecting our economics. So that is a call to continue working towards quality and coming to workshops like this and doing research and standardized testing to maintain that degradation rate low. Because also in the perspective of what we're trying to do with decarbonization, if we're degrading more, we're not producing that energy that we need to do that energy transition. So sustainability wise, again, if our modules degrade really fast, what's going to happen is that we're going to have to replace them and put new modules and make more modules. So, I mean, from a perspective, it's good because then we will have more manufacturing and more purchase, but we're also trying to produce that energy and keep that economics. In conclusion, so we have 5 years of data looking at field technologies. This is one site of 5 technologies. And while we've done a very in-depth research into the performance and all of the characteristics, I want to caveat that it's just one site. That does not mean that they are all performing the same. Who knows what they sent to the laboratory to be tested, right? Or what we were able to acquire in this small quantity. But there is definitely a need for more field experience and more field data. It is very scarce to still see these results. But yes, we're seeing some steadily declining on the performance compared to the monofacial technologies. This data is available on those Duramat data hubs. I will post the links at the end on the chat. But also there is a 1-hour deep dive into all of this results that I place here that we presented a month ago. And that is it. Thank you very much.
Okay, thanks, Silvana. Thanks a lot.